Good evening. Welcome to the ATG special event. I'm Dave Nagel, and in the immortal words of Al Haig, I'm in charge here tonight. We have what I hope is a really exciting lineup of new technologies to share with you. In addition to a surprise speaker, start things off. Actually, you've been seeing ATG, some of its advanced technology for the last 10 or 15 minutes. These are all graphics that were produced by the ATG Advanced Graphics group. What do you think? I'm going to minimize the blather because we have really a full evening. But before starting the program, I'd like to give you a little update on a couple of promises we made at last year's evening. You guys asked for better access to some of our technologies and to the results of research conducted both inside of Apple and in some of our external research programs, which supports activities in more than 50 universities around the world. And I'm pleased to tell you that because of your request, we decided to put an ATG folder on the latest developer CD, which I think is charmingly entitled Gorillas in the Disk. Has lots of neat stuff, simple applications, some demos, utilities, and a complete bibliography, which you asked for, of all the stuff that we've been doing and the stuff that our partners universities. So I hope it's useful to you. Now to get into it. With some hesitation, and we debated this, of course, as we do everything at Apple a lot before doing it, but with some hesitation, we've decided to use some of our most secret advanced technology to actually bring off this evening. So to start off, I'd like to introduce you to my own personal global agent, Pierre. Pierre is going to help me do the presentations. Pierre?
Agent Pierre, version 6.01. No, beg your pardon, version 6.03 beta 7 reporting.
Phil, I'm curious, why aren't you Golden Master yet?
I could, if you were willing to limit the number of reorgs you have planned for this summer, Dave.
Okay, cancel the reorgs for the summer.
Undo feature not available without John's clearance, Dave.
Pierre, just introduce the next speaker.
Yes. The next speaker is Don Norman, an inveterate critic of modern technology like agents.
Let me do a bit more in the way of introductions, Pierre. It's a great try. Bit mechanical. Don Norman is the author of The Design of Everyday Things, which does a much better job than anything I know of articulating what's wrong with a lot of advanced technology. Don helps ATG and other groups in Apple a great deal in eliminating certain features in our technologies which might lead to less than great user experiences. You may know him, but if you don't, Don's a professor and chairman of the Cognitive Science Department at UC San Diego, and it gives me great pleasure to welcome Professor Don Norman, who's going to tell us what's wrong with some of our stuff. Don.
So, what do I think of System 7? Well, it's an improvement. That's a standard consulting phrase, by the way. It means nothing, but it keeps people happy. So, let me start with some non-computer applications. I have some slides. The United States Post Office. Rule of thumb for design: if people paste signs on the machine, there is something wrong with the design. Now, the post office machine makes it easy to buy stamps, right? They warn the user, this machine only makes $3.25 change. Actually, the 25 cents was crossed out here and there, and they couldn't make up their mind exactly how much change they make. So anyway, it's just a typical vending machine. They just couldn't make up their mind. But what's really interesting is, can I have now the Macintosh slides? And on the center, too, please. Try that. Push a button. Well, I went to our local post office. These machines are all over, though. And I wanted to watch one. And I watched for about an hour as people used it, and nobody used it right. Now, on the top of the machine, there's an electronic display with a scrolling sign. And here's what the scrolling sign said. It said, "Welcome to the Del Mar Post Office vending machine. I refund a maximum of $3.25 change with your purchase." Think before depositing a bill larger than $5. There's only one thing worse than a machine that has lots of signs pasted, handwritten and pasted on it, and that's a machine that's so bad they have to have a special, a specially prepared sign. Now, would you trust a vending machine that said, "Think before using me"? Now, my lesson, this is a story with morals. Test, test, test. Watch your users, and learn about the users, and test before you design, and while you design, and after you design. And don't think that you know the users. You have to watch them. So you have to study your users and test and observe and do field studies before you code. Because after you've started coding, it's too late, right? No matter what anybody finds, you can't undo it. It's too expensive. Now, I'm going to do something that's out of character. That is, I'm going to say that, System 7 really did it right. They actually did. They actually made a distinct effort to use some principal design. And, they messed up here and there. I'm not supposed to tell you where, though. But they really did test actual users. In fact, I was one of them, and they even listened to me. And they even promised they'd put some things in 7.1 or 2 or who knows. But I really think that some of the features are really major improvements, and the consistency is better, and the help is a dramatic improvement, aliases, the ability to see your file structure in several different views, easily going back and forth, and the fact that it was all tested very carefully. And yeah, it took a year longer than it was promised, but I think it was worth it. And the difference is when you test. But when you test, don't test on yourself. The designers and the programmers are not typical users, okay? In fact, anyone associated with a project is no longer typical. Because once you're associated, once you're bought into it, you start to learn a lot. And the more you learn, the more you know, and the more this, the fact you have to reach behind your back and you have to type Command, Option, Escape, button, seemed perfectly natural. In fact, Apple did it. There is, in fact, still the Command, Option, Escape. By the way, it's a great improvement. I can't live without it. You all do know about Command, Option, Escape, don't you? You do now. Try it someday. It kills your application, which is what you want. It kills your application without having to reboot. Now, what I want you to do is test and retest, and not on yourselves, but on real users, and do it right before you code while you still have the ideas. You do what we call computer simulation. That is, you simulate the computer, okay? Or sometimes it's called the Wizard of Oz technique. Remember in the Wizard of Oz, it was all smoke and mirrors? Well, that's how you do your rapid prototyping. Like, you can use 3x5 cards, it doesn't matter. But try it out, or else you'll end up with a post office machine. Now, let me give you some examples. There are two different kinds of design. One of them is sort of computer-centered, and the other is user-centered. And I'm going to argue for a user-centered design, which means provide all the relevant information. Don't make your users guess. Don't make them have to ask. Apple Link. I used to read Apple Link until they got all these new bulletin boards and these new folders. Yuck. You know, the ones with a T on them? Yeah. But look at this. You call up Apple Link and you get this menu. Those of you who know Apple Link probably know this one very well. And what happens in the morning is I wake up and I turn my machine on and I tell it to go check the mail while I go upstairs and get the coffee going. So what I want it to do is check the mail just once and do it right now. Do it right now. You see, what it does is it says, when should I connect to the network? And it's always 12 hours off, whatever time I want it. It says the last time I did it, right, which was last night. Now it's this morning, so I got to scroll back and forth to find the time. But when should I connect to the network? And my answer is, as soon as you can. But it only updates like every 5 minutes, right? And it doesn't tell me what time it is now. It just tells me what time I want, but I want to do it right now. So what I do is I guess. So here's what happens. I say, connected 11:43, and when I say, boom, guess what? By then it's 11:43 and 27 seconds. And if only they would have told me the current time, then I could have done something. Or better yet, they could even say, do it now. Little button, do it now. That would be nice. Actually, after I did this talk, I discovered there is a way of doing it now. What you have to do is lie. I love programs that make you lie. See, what you do is you tell Apple Link, I don't want to do it once, I want to do it every 2 hours. And if you wanted to do it every 2 hours, then it actually does the first one right now. And then after you've had your cup of coffee, you come back and you say, I lied, don't do it again. Then there's this other thing, where's it going to put the mail? Well, it has a special thing. You can select the folder to put the mail in. But it turns out it has a really bad memory. So you set it today, and tomorrow it doesn't remember. So it sort of remembers whatever, I don't know how it knows what folder to put it in. But it certainly isn't what I told it last time. So it has this little button that says select folder. And my answer, well, if you had the right one, I don't want to change it. But if you have the wrong one, I do want to change it. Why doesn't it tell me, right? It wouldn't be hard. I mean, I can do it right here, see? I can say the current folder is file transfers. Now do you want to change it or not? The problem with this Apple Link menu is the problem with lots of menus out there is that it's computer-centered. What you did is you said, now what do I need to know? I need to know where they want me to put the files, and I need to know what time they want to connect. So I'll ask the user. You have to also take the user's point of view and ask, now, for the user to answer these questions, what would the user like to know? And the user would like to know, like, what time it is. And, well, what do you think the correct folder is now? That's simple. Take the user's point of view. But actually, if you took the user's point of view, as I said, you might even put a little button that said, do it once right now, without making them set the time. Or you might discover that users use Apple Link, say, at defined times throughout the day, in the morning, in the middle afternoon, in the evening. So they could have 3 or 4 different times preset, and they select the one they want at the moment. But you wouldn't find this if you didn't watch users. So you have to watch users and not take the computer's point of view. So you have to, here's the second moral of the talk. Give appropriate information, give feedback, keep the user informed, and avoid unnecessary actions, or let the user avoid unnecessary actions. All right, so that was the first point. The first point is take the user's point of view. The second point is what I call activity flow. That an optimal work experience means uninterrupted work. So in fact, if you're really using something well, you shouldn't be aware that you're using it. When I'm drawing with a pen, I should not be aware the details of the pen. I should be aware only of the drawing I'm doing. And when I'm using an application program, sorry folks, but I don't even give a damn about your program. I care about what I'm creating. And the best program is one that keeps out of the way and is invisible. End of document reached. Okay? Now, why do you have to do that, you know? Here I am working along, and this damn box comes up, and I can't work anymore. I got to move the mouse or reach my hand over and find the return key and say, okay, okay. I mean, great. If you want to tell me it's the end of the document, why don't you just tell me, but don't stop my work? You'd have a little message box and say end of document, or maybe you could flash on the screen for a second. Or better yet, why don't you say so in voice, say end of document reached. But don't interrupt my flow by making me stop what I'm doing and have to move my hand or move the mouse and find where I am. So this happens to be Microsoft Word, but it doesn't matter. You'll find it all over the place. Another one with Microsoft Word, which I'm writing away and I have this thought in my mind, and it should be a footnote. So I quickly select footnotes, and I'm ready to type it, but before I type it, I got to say, what kind of a footnote? You know, is it? Has to be a numbered footnote, or should it be a funny symbol? By the time I decided, I've forgotten what I'm trying to write. So, you know, it's kind of crazy. First of all, since most of us, whatever we decide once upon a time, we keep it for the rest of the thing we're writing anyway. So having one said, I'm doing numbered footnotes, so just let me continue, don't ask me. Or second, you can ask me later, I can fix it up afterwards. But don't interrupt the activity flow. You don't want interruptions. Interruptions are a real pain. Or take a look at this one. This is from Claris. This document will be reflowed, okay? And then, not only do you disrupt the poor guy and you have to hit the damn return, but you don't even know what it means, and you can't do anything about it anyway. And then, Claris has to spend 2 pages of its newsletter explaining what it means, right? Wouldn't it be nice if it just sort of just did it? Since I don't know what it is and I can't stop it anyway. Now, my last point is that system beep, 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 beep. Yeah, I can change the system beep so I can make it go guh or oink, but it's always the same, right? And another thing you guys often do is, first of all, you're computer-centered, but second, you're application-centered. You think that your application is the only thing going on at once, right? I'm running 7 or 8 at a time, and with System 7, you can expect most of your users will be running several things simultaneously. The system supports it well, and they're going to have enough memory anyway to run System 7, so they might as well use it. And so this beep, you know, it's intrusive, it's uninformative, and when you have different applications, it's bad enough now when you get those little error messages and you can't figure out where it comes from. What I discovered you can tell, of course. You can look to see what menus are up on the screen, and then maybe you can remember which application had that set of menus, you know where it came from. That's where I love this command option escape, right? Kill it. What you're going to have to do is you're going to have a unique voice, and I really mean voice in this case, a unique voice for your program, your application, so that when a message is given, instead of the system beep, which is the same for all applications, the person can tell what is going on and what it means and which application delivered the message. And I'd like to recommend speech to you. because speech, if done right, is non-intrusive, it's informative, and it identifies your product with a unique voice, unique sounds, and even, it's pretty powerful. That's why we use it. Now, speech has lots of problems. It's temporary. So if you weren't listening at the moment or some other noise came in, it goes away. So you should make it easy for the person to repeat the voice message. Or maybe there should be a non-modal, none of this OK button stuff, a non-modal message window, so it's also printed, written. So if someone doesn't like the speech, fine, they can read it. And it's there for a longer period of time. People also believe that speech annoys coworkers, but I think really these are mostly people who have never tried it. They're just thinking about it. Because, the system beep doesn't annoy your coworkers. And besides, people talk to one another and they use a telephone. And that's already, I think, more annoying than your computer talking to you. So I don't like things about Apple Inc. But Apple Inc. has done some nice things. The discrete, when you haven't used it for a while, or the file's done, you have mail. Sorry, no mail. They're not bad. Now, one of the problems, though, is, again, Apple Inc. is self-centered. It thinks it's the only thing that does mail. But if you're actually running an email program, then the note, sorry, you have mail, doesn't tell you which mail it is. So we're going to have to be a little bit better. So either you have to identify yourself, I'm Apple Inc. and you have mail. Or you might just try using distinctive voices. There's an infinite variety of voices that we could use, and we learn to recognize our coworkers just by their voice. Well, we could learn to recognize their applications by their voice. But again, you better be careful. Don't be too cute. Here it is, 2 a.m. and I'm going to bed, and I turn off my computer, and all the applications come up on the screen and then close. And then suddenly my computer says, have a nice day. And you can imagine that when I turn it off, each application has to tell me goodbye. Thank you for using computers all this evening. But you hardly used me. If you need me, just double-click. You do know how to double-click, don't you? But remember, think before using. Thank you.
Done to get things oiled up here. You can imagine what he says to us in private. Pierre, are you Golden Master yet?
I have reverted to version 7.0 Alpha 12, which is more stable and has a few more user interface features.
Such as?
Scalable bow ties.
That's terrific, Pierre, terrific.
Oh, and a brand new customizable preference panel. Let me show you.
Okay, I'll bite. Maximize attention level. Maximize attention level. Introduce the next speaker.
What is it that you said, Dave? You said something, Dave? Dave, you said something, didn't you? You're going to say
Just
something,
introduce
Dave?
the next speaker.
The next speaker is Andrew Shalit, who's in ATG's East Coast R&D group in Cambridge.
Andrew, I bet while you're getting your microphone, let me ask you a question. I'll bet there's not a person in the audience who wouldn't like better tools to speed up the development process a little bit. You guys been working on anything interesting?
Yeah, we have. We've been working on longer microphone cords, for one thing. It's well designed. Oh, use this one? Okay. Actually, I'm going to be over here, so I'll go over here. Great, thanks. The tool I'm going to show is Macintosh Common Lisp. It's, oh, no hissing allowed. It's a product developed in the East Coast lab. This is a new version 2.0, which was just released. And I'm going to be showing the dynamic features which, keying into what Don was saying, make it a lot easier to test and refine your program and actually try it out with users. Be on 2 monitors. Does that make it a little clearer? Okay, great. Sorry about that. Okay, gonna start again. There are a couple features that I'm going to be showing. This is a dynamic language, so it lets you try things out and change them very quickly, which it looks like it might be good if we could do that with other equipment right now. With software, that can be a little easier if you have the right tools. So the features I'm going to be showing are, 1, it's dynamic, so you can change your mind and make things happen very quickly, even while your application is running. 2, it's compiled, so the code that you're working with runs adequately fast. And 3, we've used these tools to build a very high-level interface on the Macintosh toolbox, so it's very easy to do Macintosh things. This little piece of code here puts up a window and then does some animation in that window, or a little bit of drawing. I'm going to evaluate that, which compiles it. That defines 3 functions. I can immediately call one of those functions to make a window with some special behavior. Okay? This is a 2CI we're running on. I specifically asked for that rather than an FX to show that even though this isn't a dynamic language and it is in Lisp, it still runs pretty fast. What this code does is, can people see both of these? Yeah? Okay, great. This is a little loop, and each time through the loop, it calls out to a drawing function. And in this case, the drawing function just calls frame rect. And so each time through the loop, it's drawing a rectangle. While our program's running, I can actually change the function which is called, change its definition. In this case, I'll change it to draw frame oval. And I can do that. I can try out a different style of my program while the program's running. I can compile that code, and my program immediately starts using the new code. You notice it got a little bit slower. That's because it takes longer for the toolbox to draw circles than to draw rectangles. And that points out that in a lot of applications, a majority of the time is spent in the ROM in a lot of cases. And the small amount of overhead that you have in a dynamic language doesn't really hurt you that much. The last drawing part of this I have shows off System 7 a little bit. You have a nice smooth little TrueType 7.0 there, and it slows down a little bit more again because it takes longer to draw 7s and do a big bit blit than to draw a rectangle. So that's nice from a programmer's point of view. It's nice to be able to change your application and see what it would look like a different way without even leaving the application. It's really an amazing prototyping tool to be able to do that. It's also nice to be able to give capabilities like that to the user. You wouldn't want a user to have to select a piece of code, for example, and hit the Enter command in order to change what's being drawn in a window. And we have another tool in the list, another dynamic tool that lets you take the functionality of your program, functionality which you've already created, and easily plug it into a user interface. This is the dialog designer. I can make a new dialog box, and what I'm going to do is drag 3 radio buttons into the dialog box and attach an action to each one of those. And in this case, the actions are simply going to be to compile those 3 definitions and install the 3 different definitions that we had for the drawing program. You can double-click that and call it rectangle. And I'll copy the frame rect definition and paste it in as the action of this dialog item. And I'll do the same, make this a little bit bigger, I'll do the same for the oval. Copy this definition. Double click. Oval. Set its action to be that definition. And the last one is System 7. Oh, looks like I dragged something off the window, so I'll just make another one because that's fastest. We'll call this Big Bang. It's finally exploded. Hopefully I can copy that. And set its action, the action of that radio button. You'll notice when I click on these that the radio buttons know that they're in a group, and so only one of them will be selected at a time. So I can go now, and the window's over there. If I go to use this dialog, I should line things up a little, but I think I'm a little late. And clicking on them does the right thing. There's no magic here. The window is still running. And then if I decide I like this dialog enough, I probably should clean it up a little if I really wanted to keep it, but I'll skip that part tonight. I could then print out the source code for it. That's done by simply asking each object in the window to generate its own source code. I could take that and copy it. Nice little intrusive dialog there. And paste it into my application and save it and use it and possibly even re-edit it later. So, oh, that's not the one that I want to save. In any case, that's it. Thank you.
The beauty of a modern programming language. That was great, Andrew. Andrew's been showing us some of the, actually some of the features of MCL 2.0. Andrew, could you talk for just a second about some of the other features?
Sure. The main new features are compliance with the new Common Lisp standard. So it has a standard object system and a bunch of compiler improvements, inspector improvements, debugger improvements.
Great. Thanks very much. Pierre?
Yes, master.
Well, I like the idea, but just call me Dave.
Nagel.
No, that's not it. Hold it. Stop it. Abort. Pierre, get that crap off the screen and just introduce the next speaker.
Our next speaker is Eric Anderson, one of our chief sound winnies in ATG's Systems Technology Group.
Eric, I've been hearing a lot about real-time processing and multimedia and all that sort of thing. And in fact, I've been hearing a lot of how it brings CPUs to their knees. Are you guys going to work on some technology that might help them in that?
Yeah, we have some pads for the knees, actually. See, I can't see the screens from here. Is everything okay? Okay. All right. What I'm going to show you tonight is a demonstration of an integrated DSP into the Macintosh architecture for the purpose of... Gee, that was good. I guess I'm done. That was... Hey, Pierre. Oh, forget it. Okay. For the purpose of extending the Macintosh into real time. A little background first before I start the actual demo. Can't see any of you out there. Of course, the lights are so bright, so I'm just trusting you're still out there. We started looking at where the future for sound would be for the Macintosh. That's how we started. And after a certain amount of study and investigation, we came to the conclusion that the right direction was a programmable DSP. However, before I go any further, I probably should explain to some of you what a DSP is. It's not something that everybody knows, except for sound weenies, of course. DSP stands for Digital Signal Processor. It's basically a general purpose programmable CPU chip that has certain kind of extensions that make it possible to process very quickly what we call sampled data, which is essentially any real world natural thing that you've digitized in the form of images or sound or whatever, temperature samples, anything you want to do that's from the real world. Some examples, of course, that we're particularly interested in were sound and image. After we came to that conclusion, we realized that DSPs could be used for a lot of other things as well, and so we decided that we needed to take advantage of that. Things that I'm thinking of in particular are like speech processing, speech recognition, text-to-speech, modems, data compression, both lossless and lossy, telephones. There's just a lot of different things that you can use DSPs for. So we changed our goals a little bit. We decided to come up with a hardware-software architecture that would basically be multitasking, would support multiple clients. That is to say, you could have several different applications utilizing the signal processing services without interfering with each other. And we, of course, had to do some tools, lots of functions, and finally, what we're going to show you tonight, some applications, both to test what we had done and also, of course, to demonstrate it. At Apple, by the way, most of the upper management, and in particular, John Scully was born in Missouri. And that means, I guess you probably know what that means, show me. That's a show me state. So you can't show them, doesn't count. Underlying the demo that you're going to see is a tightly integrated coprocessor architecture. It has what we call dual-threaded. It has two task threads. One of them is real-time. One of them is what we call timeshare. The real-time is for things that need to be done on time. They can't be late. Sound is a good example of that. You don't want gaps in your sound because the computer is too slow. And the interesting particular part about that is a thing we call guaranteed processing bandwidth. So if you ask for a certain processing load, you're guaranteed it'll always be there. Example of a real time would be like sound. Timeshare is the other task list, and that's basically something that is whatever's left over. There's a lot of unused processing left over, and it varies depending on the load in the real time, and we use that for non-real time tasks, as you'll see in the demo shortly here. So let's start off on the screen here. In order to get a comparison, we have here, by the way, a 2CI and a direct slot card. I'm going to start off with a comparison so you know how to view what we have here. This is the Macintosh itself, 68030, 25 megahertz, doing a teapot animation in 3D line drawing, just so you have a reference. Now I'll bring up a version of the same program that's running on the DSP. There's that beep. Computers will never be the same now that I heard that talk tonight. Anyway, as you can see, that's somewhat faster. This is running in timeshare. That means it's running as fast as it will go. It's a joint load between the host and the DSP. The DSP is doing an off-screen bitmap, and then the host is blitting that to the screen, mainly because we didn't want to teach the DSP all about Windows. Okay, here's a second version running at the same time. We'll just stick it over here. And you can run as many as you want. Of course, as you run more and more, it slows down, obviously, because it's doing essentially round robin. But it doesn't run half the speed because now you have true simultaneous processing. Before, when you had one, you had the DSP did its work, it stopped doing anything, then the host did the bit blit, and then the DSP did its work. Now you actually have shared processing simultaneously. Now I'm going to leave this guy up. I'm going to shrink him down so it doesn't take up so much space. You'll see he runs a little faster. And this is kind of an indicator of kind of leftover DSP processing. Now actually, it's not entirely that. It also depends on the host because it really is a joint effort. So naturally, if, for example, I hold the mouse button down, it stops because the host is busy waiting for me to let my finger up off the mouse. That's kind of an interesting design feature of the Macintosh. Okay, the next item I want to show you is playing multiple simultaneous compressed soundtracks off of disk. I'm opening up 5 different channels of weird sound, and I'll try to mix them in some meaningful way. Whoa. Here we are in the swamps of Apple Computer, and we have a lot of reorgs, so we have to do a lot of construction work. And of course, we live right on a major thoroughfare, so every once in a while when you're working along, anyway, just to show you that as an example, here's running 5 different, I don't want to play that car thing over and over again, it drives you crazy, but we can run 5 different simultaneous decompression algorithms off of disk, real time, and mix them. And as you can see, the animation over here is still running because there's still some excess processing time. I don't know about you, but the noise drives me crazy, so I'll turn it down. Okay, now that's not using all the DSP. Clearly, you can see the little teapots turning around down there. So let's bring up another example of an interesting application, the telephone answering machine. Now notice the teapot stops because the host is busy loading the application. But since everything is interrupt driven, the sound keeps playing just fine.
I'm not in right now, but you can leave a message with my Macintosh.
Hey, how you doing? I got a great idea for your demo next week. And by the way, watch out for Pierre. He's a real tricky guy. Okay, now you see on the icon here indicates that a telephone message has been received. I can either come back to my desk and pick up the phone call, or I can call in and get it. Now, I should mention, by the way, that this telephone application actually uses on the order of 11 different tasks, including DTMF detect and compression and decompression and lots of other things all at the same time. In this case, I'm going to enter my secret code.
I'm not in right now, but you can leave a message with my Macintosh. You have one message waiting, and it is... Hey, how you doing? I got a great... Press 1 to save this message, or 0 to delete it.
Oh, well. This has got the same bug that Pierre has.
There are no more messages.
And that's basically the demo. What we have shown you is the incredible processing power extension that integration of a coprocessor, a different kind of coprocessor, a dissimilar coprocessor into the architecture can give you.
Eric, that sounds great. Sounds like it might be a little expensive. I hope this is not like one of Bill Gates' cars. Fantastic, but you can't drive it.
No, I don't think so, but then I don't know much about Bill Gates' cars.
Pierre?
Yes, Dave?
Pull in your information store and introduce the next speaker.
Oh, you will like this new pull-down menu.
Just do it.
Our next speaker is Kevin Teen, who's in the application frameworks in ATG.
Kevin, we've been seeing firsthand here some of the negative potential for the use of agents in computing. Are you going to show us something a little more useful than our friend Pierre up here?
Yeah, I sure hope so. You know, when Don Norman was talking about what a great idea it was for computers to talk to us, it seemed like such a good idea at the time. And, I wonder now. Okay, so I'm here to talk to you this evening, and I want to make it perfectly clear. I'm only on one monitor tonight, okay? So don't throw anything. So anyhow, I'd like to talk to you about a project we've been working on in ATG called Rosebud. The charter of the project is to study content-based applications and try and discover what additional features might be needed by our system software in order to support such applications. We've chosen the metaphor of newspapers, reporters, and notebooks as something that people could relate to. The idea being that we create these agents that we call reporters to go off and find information for you and bring it back, and then every day they would take that information, dump it into a newspaper, just like your daily newspaper that comes to your front door, and you can come and check it out every day. So let's jump right in. We've already got the application running here, and what I'll do is I'll come under the reporter menu and create a reporter. The first thing I need to do is tell the reporter what to look for, where to look, and how often to look. So let's say something like, is Dan Quayle qualified to be vice president? Oops. Fix that up here. I'm a terrible typer. And so that's our question. Now we have to tell them where to go look. And right at the moment, we've been working with a couple of different data sources. One of them is coming off the internet, and it is a pay service called Clarinet, and it's essentially UPI wire. And that's what we're going to have him look at. That's about, I think, about 13 megabytes worth of stuff. Another one down here is a recreation server, which is just a bunch of hobby topics that we're all interested in. That's about 58 megabytes or something the last time we looked. I've been asked to mention that we are in fact hooked up to the engineering network back at Apple Computer. It's an amazing feat here this evening, and it's being done through an SMDS, which is a switched multi-megabit data source. So marvels of modern technology, we hope. The other thing that I'll ask this reporter to do is, since I like to keep an eye on old Dan Quayle, that I want him to go ahead and do that every day. Okay, so we're going to say, is he qualified? Go look here and do it every day. So what'll happen now is there are a whole bunch of components running on this machine. This is written actually under System 6. So there's a couple of faceless background tasks and all sorts of weird stuff. But what they do is they send this information out. It goes out over the net. There's a server back in Cupertino. It's got some of this information indexed, and the answer comes back over here. Okay. The results that we have back here. This one's sick. Okay. You didn't see that. I know you did, but. The results that come back are ranked based on how appropriate the server thought the responses were. So if you notice, this one here has a 5-star rating, and it goes on down from there. And we just asked it to bring back 10 items and whatnot. So let's take a look. You see, the top one says, talking about dumping quail. That looks like an interesting one. So once again, it goes back and goes to Cupertino and pulls back just a little preview so we can see if this is an article that we're interested in. And you can see it highlights why it thought it was an appropriate article. And sure enough, ever since George Bush has gotten sick, people have started getting real nervous about old Dan Quayle. There's a little plug for dynamic languages also. You notice dynamic languages are much too slow to do real-time color text scrolling here. That's his Digitalk Smalltalk V, if anyone cares. So now that we have found that this is a good query, we'd want to be doing this all the time. So what I'll do is I'll just go ahead and close this reporter and say, yes, I do want to save him. I'll just save it under his full title here is Dan Quayle Qualified, ... And that's great. He should pop up on our machine here any minute now. And now all I have to do is every day I could go back and I could look at that reporter and see if he's brought in any new information for me. Well, if I had too many reporters, that would get quite tedious. So what we did was we had another agent go around every morning and talk to each of these reporters and find out what they had found, what new information they had pulled in since the last time we cut a newspaper. And that happened this morning. So I have my newspaper from this morning. We'll just take a look at it here. Open newspaper, go to News of Wednesday. And what we have is we have a newspaper that had 2 reporters at that time contributing to it, Stratocaster Pickups and Typhoon Hurricane. So I like to keep tabs on very strange things. Always interested in buying new pickups for my guitar, so that's a good one to watch out for. And what we can do here is we can see each of the reporters has a byline, and he gets to lay out his favorite or his newest articles into the newspaper. So we can scroll through and see just a little blurb on each one, and if it looks interesting, we can double-click on it, and it will go out and fetch the whole text of the article. Okay. At this point, you could go ahead and print or save or do whatever you want with these articles. I should mention there's a third part of this that we have designed but not implemented that we call notebooks, which is, once you've got all this information being pulled in, now you've got a problem with what to do with it. You don't want all these just separate files floating around on your disk. And we have a thing called a notebook where the information, you could associate reporters with notebooks. The information would naturally flow into the notebook and be organized. And you can do things like annotate and mark up things to email to your coworkers and whatnot. We haven't done that, but if anyone's interested in seeing that, there was a paper given at this year's SIGCHI. And if you look in the proceedings, there's some stuff in there about it. So I guess that's pretty much all I wanted to show you. The fairly simple protocols to talk to each other. So the idea behind that is if one of you all come up with a better search agent or better servers or a different interface, you should be able to just focus on what you're good at and do that piece, plug it into this system, and it should all just work. So that's about it.
Kevin, that was great. How do your agents talk to one another? What sorts of protocols are you working on?
Yeah, the agents have a couple of different protocols that they speak to each other. The most interesting one is something called Z3950, which is an emerging NISO standard for information retrieval. I think it's come out of the library community. And if anyone's interested, they might want to keep their eyes and ears open for that.
Very good. Thank you. Pierre,
Yes, Dave.
have you detected any kind of a pattern in the proceedings yet?
Yes, Dave. You're going to ask me to introduce the next speaker.
So as we have demonstrated here tonight, agents can be made to, under certain circumstances, detect certain patterns in user behaviors. Go ahead, Behair.
Our next speaker is Alan Cypher. Alan is with our Intelligent Applications group. Alan has been working on tools for making programming so easy it disappears.
While Alan's getting set up, I should point out that while Alan is in the Intelligent Applications Group, contrary to rumor, we do not have a stupid applications group in ATG.
Okay, thanks. Great. Okay, I'm going to demonstrate a programming by example system. It's called Eager, and it's designed to detect patterns in user activities. And I'm going to show how it can be used to automate repetitive tasks. So in this example, I have a hypercard stack of mail messages. And what I'd like to do is make a list of the subjects of all of the messages. So I'll go to the first message and select the subject. I'm going to copy it and then paste it into the first card. And now I'll go to the second message. And copy its subject and paste that into the first card. And at this point, Eager pops up on the screen because it's detected the pattern in my actions. And it uses this green highlighting to show that it's expecting that I'm going to click on this button next. And in fact, that is what I'm going to do. And now it uses the green highlighting to show it expects me to select this subject, to do a copy text command, go to the first card, click here, type 3 period, and now it expects me to do a paste text. So at this point, I'm confident that it knows what to do. And so I'm going to come over here and click on Eager, and I can just let it finish the task for me. Okay, that's it. Thanks.
Al, that was great. Since you got through it so fast, maybe you could take a minute and tell us a little bit about the software. You know, and how general it is. Does it only work with HyperCard, or?
Sure, let me describe just a little bit how it works. Eager is a separate application that runs in the background. And whenever the user performs an action in HyperCard, HyperCard sends an Apple event to Eager. And Eager keeps, I think they're wonderful. I'm very glad we have Apple events in the system. And Eager keeps a history list of all these events, and it looks for patterns in them. And then if it finds a pattern, it sends Apple events back to HyperCard to tell it what to turn green. So it's designed so that it's completely independent from HyperCard, and you need a file with some declarative information that tells it a bit about HyperCard. But any application, you know, the hope is that eventually any application that sends Apple events to describe all the user actions, and if the application includes a way to highlight items in green, then it should be able to take advantage of this.
With some trepidation. Pierre.
Hey, c'est toi, Dave. Salut.
I can see you improved the user interface a great deal, Pierre.
Ah oui, Monsieur Nagel, et le prochain présentateur est un dénommé
Can
Kurt
it
Schmecker.
convert that to English, would you?
Oh, un instant, s'il vous plaît. So you really want me to speak in that barbarian language?
Read my lips.
Our next speaker, Kurt Schmecker, is also with ATG's East Coast R&D group.
Kurt, while you're getting wired up, when I used to do real work before VP'dom, as it were, I always wanted my very own supercomputer, but they always seemed a bit pricey. You guys been working on anything that could give me that kind of performance at, say, the price points of a Macintosh?
Yeah, Dave, that's exactly what we're trying to work on here. The application I want to show you tonight is called Tangram. And what Tangram is part of a project at ATG called the Scientist Workbench, in which we use real-world scientific problems to push a variety of technologies. The application's name, Tangram, comes from the name of the Chinese puzzle. It looks kind of like this. In that puzzle, people rearrange pieces in interesting and unusual shapes. And that's kind of appropriate for Tangram, because what the Tangram user does is take high-level building blocks and rearrange them to solve a given task. It's interesting in Tangram because those building blocks can run on different machines. They can be machines in the back room or even machines all the way across the country. The machines we'll be using tonight include this Macintosh FX, the Apple Cray in Cupertino, a graphics mini supercomputer, a Stardent, in my office in Washington, D.C., and the Cray at the University of Illinois' National Center for Supercomputing Applications. Now, the interesting part about this, of course, is the networking. Tonight, we're connected to the Apple Secure Engineering Net. We're also going to be using a line that goes from that net to my office in Washington, 56 KB line. And we're using, as did Kevin in a prior demo, an experimental SMDS, switched multi-megabit data service network that was installed specifically for tonight's demo by Pac Bell. This network is a cell-based wide area network similar to that which is being proposed for the National Research Education Network. And it was installed by Apple's ATG Broadband Communication Research Group together with Apple's Engineering Computer Operations Group. And Pac Bell and Cisco sort of donated equipment and gave us a lot of help, and so we're really quite appreciative of that. It's interesting when you do problems like this, you're subject to a lot more anomalies than you are operating on an ordinary Macintosh. For example, 2 days ago we were doing through a dry run of this demo. We tried to connect to the Cray at NCSA and we couldn't. So we tried to connect to another machine at NCSA and we couldn't there either. Found out after we made a couple of phone calls that there was a line of tornadoes going through that portion of Illinois at the time, and all the power was out in that part of the country. So tonight, if there's no tornadoes in Washington, in Illinois, or in Cupertino, our demo should go okay. Well, here doesn't matter. The problems we'll be using tonight are scientific problems because scientists have the most difficult needs in this area. And what we hope to do is if we solve the most difficult needs, the other ones will be easy. In fact, we try to consider Tangram as sort of the personal environment for complex systems where people have to use remote machines. For those of you who don't have Crays in your back room, don't worry. There are a number of spin-offs of this work, especially if you use Mac app, that you'll be seeing on developer CDs in the near future. Okay. While we've been talking, Tangram's been querying the remote machines and seeing what components are available. So let's double check and see what's there. And these are a list of components we can use tonight. This one displays an image runs on this Macintosh. We'll use this a lot, so I'll lay it up here in a little holding bin so we can get at it easily. This particular component runs on the Cray at NCSA. Notice when I activate it, its borders are gray and then they turn black. That's because they're gray when I request the service and they're black when the service is actually confirmed. I need one more component for this first demo, and that's just a control panel that will allow me to send some numbers to the process running in the Cray at NCSA. If I drag down now this component, I can complete the tryout I need for the first demo. And as I connect them, you'll see the same phenomena here of the gray going to black when the connections become actually established. There we go. And one more. All right. This particular component these are going to retrieve some images of some intergalactic shock waves that have been simulated at NCSA's astrophysics group. All I'm going to do is send them some parameters telling them what images we want returned. I'll get one that I know is going to look pretty interesting for tonight. Now what we're doing is requesting that the process at NCSA return over the internet through the SMDS network connection a 32-bit image that was computed at a simulation on the Cray at NCSA earlier today. You can see that image here. It's kind of a shock wave spherically spreading out from the center. For those of you that are not astrophysicists, this is a big shock wave. This would be sufficient to knock the Enterprise out of warp space. It's a major deal. And one thing I want to point out is when I establish a connection like this, that's a point-to-point connection. If these were two Crays, for example, the MAC is not the center point or not a bottleneck. I've established a direct connection between those two machines, and that's very important. You can't have the MAC being the bottleneck if you're using several supercomputers simultaneously. Now the user interface we used here was a little bit crude, typing in numbers and stuff. Let's do a little bit more fancy one. Here I have a component called a Mars selector. You'll see how that works in just a moment. Let's use a different supercomputer. The NCSA one we've checked out. Let's check out the Apple Cray. We're getting some pictures also here. Request some connections. A little bit of sonic feedback. Now you might wonder what these shapes are that I've pulled down here. We decided to use an idea that the Human Interface Group came up with some time ago, and that's three-dimensional icons. And so these are icons in cubes, and each side has a function. For example, you see here, output pins and input pins. What if I needed to know more information about that output pin? All I have to do is mouse down on the side of the cube. It rotates over. It tells me the kind of data that cube sends out, or the name of that pin. In this way, the user has at their fingertips the information they need to deal with the process at hand or the task at hand. So let's open up this window. And let's get a little bit better control, a graphical control, instead of a numerical one like we used in the last example. And what this will do for us is allow us to get some scenes from Mars that have previously been rendered and are stored on the Apple Cray. The particular images I'm returning tonight are ones that were used in the Mars Navigator project at ATG. If you haven't seen that, I strongly urge you to go across the street to the San Jose Technology Center and check it out. It's really quite impressive. Now the images I'm getting here are full 32-bit images. I often leave the machine in 8-bit for some speed and other operations. Well, just let me show you that they are 32-bit images. And of course, I can retrieve another one in the same way by just mousing down here. What we hope to do as we further develop this is to improve the speed sufficiently so one could actually interactively steer around the surface of Mars with an interface like this, or steer a simulation that's interactively running in the background, thereby giving the Mac user the feel that they're at a supercomputer, when in reality they aren't. Now we did have one issue that I thought you might be interested in. The it gets a little confusing when you have lots of components up here. You might say, well, gee, I'm not sure where things are running, and I'm not sure what's going on exactly. I've lost track because the arrangement of components I've got here is just so large. We did add two ways of dealing with this. The first way is, you notice these are cubes, and you can rotate in various dimensions. I show you rotating side to side to show the pins. I can also rotate down to show the machine it's running on. Now that works, but it's kind of like the game of concentration. You have to sort of remember where all the cards were. So we decided to add another way of showing where the machines were, which I can show you in just a second. And that is to say, gee, will all you components please go to the machines that you run on, and let me see what's happening now in my computation. And of course, now go back. And that's the end of my demonstration. Thank you very much.
Kurt, that was fantastic. Now all I need is a friend that has $10 million. Pierre?
Yes, Dave?
Terrific. I see you're now learning to control some new media.
Oh, yes, yes, Dave. Our next speaker is Jonathan Cohen. Jonathan is in the Human Interface Group, but he's been working with the QuickTime project team for the past 10 months. Okay, I don't have much time.
Jonathan's in ATG's Human Interface Group, but as the agent has already pointed out, been working with a QuickTime product team. We actually have a whole lot of people in ATG that are working directly with product groups. And we've been doing that for the last couple of years. Jonathan, does media control have to be hard for the user?
Well, we hope not, but that's what I'm going to try and show you tonight. Thanks. Sound. Did you hear my answer? Do you care? Okay. I'm going to show you some work that has come out of the Dynamic Documents project, which is led by the able and talented and dynamic Dr. Michael Mills. He's also my boss. He's going to kill me for this. What I'm going to show you is applications of direct manipulation and what you see is what you get to the problem of how you might edit some video once you've got it on your Macintosh. I think you've seen the last couple of days, if you've been to the QuickTime stuff, that video on the Macintosh is a reality now. And I want to show you some of the ways that you can work with that video. This is a prototype that's running in C++, so it's actual code. And let's see, what else to say about it here? I mean, not to say that, oh, that was really dumb. Okay, sorry. The other stuff that you saw tonight was also actual code, but I just wanted to prove that this was too. What I have here is a couple of little videos running on the Mac. And what I want to do is I want to juxtapose these things. The very simplest way of juxtaposing two things is to put them together. Hello. There we go. So what I can do is just group them. And now I have one movie just appended onto the other, so I have an octopus and a monkey. But maybe what I really want to do is put the two movies together with some sort of transition in between. How might I do that? What's a nice Macintosh direct manipulation fashion? Well, let me pick up the monkey and the octopus and show you, oh come on, that was easy. What I want to show you is what you see is what you get thing. What I've got here is a wipe right. I think you can see that. And what I want to do is apply that wipe to the two images that I've just put together. So I have a first movie, a wipe, a transition template I call it, and a second movie. And I just say make the new movie. And what it does is it looks at the template, says here's a template, here's a movie. You like it? Okay. Well, maybe the wipe right was like too simple and I want to do something like more fluid and more California. So I'm going to drop this down. And what this is you could call it an iris out off center. You know that in the past, what you see when you get a transition menu, when you want to do transitions in a program, is you see like a menu of names. And you can imagine seeing wipe right off center in the menu of names and wondering what it is. But here it is, and you can see it, and so you get some idea of what's going on. Thank you. I want to show you just quickly one other thing that turns out just kind of fell out of this interface. This stuff is less clean looking and the interface isn't quite right yet, but I just kind of want to give you some idea. I made this little title frame here in Mac Paint, and it says this is a title. And what I want to do now is have it scroll down over. So you see I'm using a template where the first thing is scrolling down over the second, and I'm just going to drop that into the factory, and I'm going to say make the new movie. And I kind of get it, but there's this problem, right? I'm hiding what I want to show. So I'm going to steal an idea from video here, and I'm going to say set the key color. Please ignore the interface here. It's transitional, so to speak. And you can see now I'm showing through the title. Okay. Now, this is almost the movie I want to make, but it isn't quite. What I really want to have happen is have the letters come down and stop, and then continue. So there are a couple of ways I can do this. First way is I can play with the movie. Now this interface is really bad, so don't even look at it, okay? But what I'm going to do is I'm going to stop the movie at this point, and I'm going to say, okay, well, like lengthen yourself, all right? You see I'm getting a Silicon Valley. I say like lengthen yourself, okay? And it like continues. Isn't that like cool? Okay. But that's not what I wanted because the movie's stopping and I don't want like a, you know, what is it, Streets of San Francisco effect? I want something that's more fluid and more California. So what I'm going to do is I'm going to go into the transition template, and since it's just another movie, I'm going to have the same horrible interface that I wanted you to ignore before, and I want you to ignore it again. But this time what I'm going to do is I'm going to lengthen that frame of the transition. So now when I close this thing and I make my new movie, except for some floating point programmer errors that I'm to blame for, you get pretty much what you want. The only other thing that I want to tell you about this is that these transitions are Macintosh resources. That is, anybody who's willing to use res is perfectly able to create these things. And so a couple of weeks, you know, I went sort of bananas, and I created a whole bunch of these things. And so they just sort of run. What the direction that this thing needs to go in is to make these things easy for real live people to make rather than res editors. I think that's all I have to say. Thanks a lot.
Okay. Pierre.
Dave, hold on. Dave,
great. I say we have a new global user interface.
No,
looks a little familiar.
hold on. Dave, is this the proper place to keep your agents?
Read the teleprompter, Pierre. Stick to the script. Hey, I like your new earring, but no ex-executive agents. Beat it. I'll do the next introduction. Honk if you love Jean-Louis. Okay, I want to introduce next Lori Vertelny, who's also with the Human Interface Group in ATG. Come on up. Lori's been working for the past several years on interfaces for computer-like things that are a little smaller than what we're all used to dealing with, at least until now. Now, there's a lot of interest in computers you interact with pens and stylus and, you know, in some cases even speech. But particularly the ones with pen and stylus, the ones we've seen so far, don't seem to recognize handwriting really well enough yet to make me want to use them for things like taking notes or writing a letter. They work, I must say, they work pretty good for things like filling out forms and some of the vertical applications we've seen. But Lori's been working on some pen-based prototypes that allow you to take notes in your own handwriting, but still be able to find things and organize your notebook better than the old paper and pencil method. We hope this demo works. Actually, we tried this, and I hope that, that you can actually see enough of it to make it useful. We were going to show a videotape, but we decided that the impact of actually a live demo would be a lot better. So, Laurie?
Okay. Hi, can you hear me? Can you see me? Can you see what's on the screen? Give it a minute. Let's take a second. We've never tried to demonstrate something so small on a 30-foot screen. You see it? Okay. What I'm going to show you is a notebook computer, and what we're looking at is something that was based on a lot of user input. We notice that a lot of people who use computers now use keyboards, and that's not necessarily appropriate in meeting situations. So what we wanted to do is provide them with a computer that would give them sketching and annotation abilities. So I basically have a pen here, and I have a paper metaphor. Now let's pretend we're in a meeting, and somebody gives me an assignment. I'm supposed to do some sketches by Friday. So let me just write into here, sketches, my hand's nervous, by Friday. And it's a very easy interface to just write my, can you see that? Okay, so now we move on. Once I write into my notebook, I'm going to want to flip pages to move from one page to the other. You can see now? Okay, so I wrote in here. I'm going to show you how I can write in here. Okay. Actually, you can see if I press it a little harder, I even get a thicker line. Ooh. Now, if I want to flip pages in my notebook, I use my finger, and I just grab an edge and flip. And it goes forward and backwards. But let's say I want to see several pages at a time, or sequentially. I can just flip a little faster. And when I see a page I want to stop at, I just press down with my finger. This is really nice because when you're using paper notebooks, people don't pay attention to that keyboard in the middle of a conversation. They don't know what I'm doing. Okay. I could be doing homework or something. Okay, the next thing I do in the meeting is somebody says, well, gosh, do you have the budget that you've been working on? And since I've been working on it a lot, I want to have access to it really quickly. So I have something called an electronic paperclip. And I can mark any page in the notebook with a paperclip. And when I do, I just press on it. It'll take me directly to that page, so it's easy for me to find. And paperclips can be thrown away just by dragging them down. Or I can bring up another one just by pulling it back up. Now let's say that somebody asked me about a phone number, and now I'm on the page that phone number was on. You notice here it is in my notebook. Now, there are times when you're going to want to take information that people give you during the meeting and catalog it somehow or label it so you can get back to it later on. And phone numbers are things that you usually do that with. So we have something at the bottom of the screen down here called a stamp dispenser. And what stamps are labels for users to sort of quickly grab meaning and associate it with something on the page. For example, I may have a to-do stamp or a calendar stamp. And I have a phone number stamp in my stamp well. So I can pull a phone number stamp out and stick it on the page here next to the phone number. Now this is going to be useful later on when I want to turn on, I pull out the wrong stamp, but I can throw it away and do it again. And I keep doing it. One more time. Here we go, right stamp. Okay, so now this is going to become useful later on when I want to go find this phone number. What I can do is turn on the phone number filter. And what I do is come down to the stamp well, press on it. Wait a minute. Here we go. And now you'll notice that the stamp blinks. And that's to tell me the filter's on, but also every time I start flipping pages, it goes to the next page in the notebook that happens to have that stamp on it. There may have been 10 pages between this page and that one, but it's narrowed down the search for me. Now I can continue to flip through these pages quickly, and you can see there are only 3 pages in this whole book that have that stamp on it. And when I'm done with the stamp, I can just simply drag it off the screen. Okay. Now, there are times when you don't have to go searching through your notebook to find things, though. So you're going to want the computer to actually bring the information to you. And so we thought, wouldn't it be nice if there was a tool for doing that? So for every stamp, there should be essentially a list view of those stamps in your notebook. So I have a stamp in my notebook for labeling page titles. I call it my table of contents stamp. And what I can do is open up my table of contents list. And what it does is brings forward into this box here all of the objects that I've marked with that stamp. So it's nice because it gives me an overview of all the things in my notebook that have that stamp next to it. But above that, I can use this particular view to navigate directly to that page in the book just by pressing on it. So it's an additional way to get to a piece of information. Okay, finally, when we looked at users who use paper notebooks, we noticed that they like to organize their notebooks into different sections. And so we let people do that here in the electronic notebook as well. You'll notice that I have a tab at the top of the screen here, and I'm currently in my notes section. But I may also have a section in my notebook called an inbox. And to go there, I just press on it. And okay, I've programmed this notebook so that when I connect it to a Macintosh, it brings in all my electronic mail and stuffs it into this section. So what I'm going to do now is open up a piece of mail. And here's the piece of mail that came from Apple Inc. earlier on during the day. Now, I may not be connected right now. Well, I'm not connected. Here's the mail. But when you bring in stuff from the outside world, such as Apple Inc., you may have a problem because you didn't create it in your notebook, and it may be a little longer than the page in the notebook. So what I'm going to do is take the page and scroll it up with my hand. And you see it continues to scroll until I stop it. Okay, so the nice thing about this is the computer knows I'm not writing, that I'm scrolling, and it knows when I'm flipping the pages, and it knows how to keep all those different actions separate. And as a user, it doesn't matter to me. That's how I want to interact with it. Now, let's say that we're in our meeting again, and everybody in the meeting decides they want a copy of this mail message. So what I can do is pull out my mail stamp, and it opens up into a dialogue. And basically what I'm going to do now is program my notebook to take care of forwarding this mail to everybody in the meeting. So I have my Rolodex here, and I'm going to click on that, and since I converse with the people in the meeting a lot, they're included in my Rolodex, and I'm just going to select them to send this mail message to them and close up my dialog box. Now you notice down here that my stamps changed to reflect the state, saying that it's going to mail this to somebody later on when I eventually connect to the network. And I really like this because it makes me feel as if the task is complete even though I'm not done. When I take my small computer back to my Macintosh, it'll complete it for me. Okay, now I think there's one more thing I was supposed to show. Well, gosh, let me hit my remember stamp and see what it was. Oh yeah, these are the people that helped build this notebook with me. That's it, thank you.
Laurie, thank you very, very much. Well, I'm afraid that just about does it for this year. I'd like to thank all of you for being such a great audience, and I guess I should probably thank the wine steward for his part, or her part in that. And I'd particularly like to thank all the people who did all the hard work in bringing all these demonstrations together, as well as the people that do the technology. I hope you enjoyed what you saw tonight, and I hope you'll be back next year. We'll have an even, well, not greater maybe, but we'll have something just as hot to show you next year as this year. Pierre, it sounds like they want you back.
Yes, Dave.
Pierre, it looks like it's winding down. Bonne nuit, Pierre.
Bonne nuit, Dave. Un mouton, 2 sheep, 3 sheep, 4